So first we'll see rank using minus and echelon form. If in exam they give you find rank using minus, you'll do this method. If they ask find rank using echelon form, you'll do I'll method. If they didn't ask any particular method, then you can do any convenient method you can like. Okay. So first using minus, so we have to the definition of the rank. See, so a matrix is said to be of rank R if it has at least one non-zero minor of order R. So this is 3 cross 3. First we'll see for this minor. See. So the point behind this method is we have to show that determinants are 0. Determinant of 3 cross 3 is 0. Then rank cannot be 3. If determinant of 2 cross 2s are also 0, then rank cannot be 2. So we have to show that there is one determinant such that determinant so rank exists. So firstly, I want to show that this determinant is 0. For that, I don't want to find the whole, the conventional method. So easily, I'll make zeros. So that determinant will be easy to find out. So I will make zeros everywhere possible. So first, I'll write row 2 R2 minus R1. So now this becomes, and R3 also 2 minus, so R3 add 3 minus 2 R1. So always when you're performing first time, this one should be R1 only. Okay. So 0. Sorry, first row will be same 1, 2, 3. Second row will change 0, 2, minus 1, 0, 2, minus 1. So now next R3, R3 minus R2. So now I'm doing it for second time. So this whatever I do, this side should be R2 only. First time R1 only should be there, this side. Okay, so now this becomes 1, 2, 3, 0, 2 minus 1. So 0 minus 0, 0, 0. So see, determinant is 0. If one row is all zeros, then determinant of 3 cross 3 is 0. Therefore, clear third order minor is 0. So rank of A cannot be 3. Okay. So now 3 is done, no? So we'll go into deeper. We'll check for 2 cross 2's. We'll check for all 2 cross 2's. If at least one 2 cross 2 minor is some numeric value not equal to 0, then 2 will be our rank, like that. So see, we'll check for this, we'll check for this, we can check for this, we can check for this. So any one you take, for example, this 2, 3, 2 minus 1. Rank will be, if I consider a minor 2, 3, 2 minus 1. It's minus 8, okay, which is not equal to 0. Therefore, rank of A is 2. So non-zero minor, if at least one is there, then that order will be your rank. So this method is using minors. So you understood zeros are not needed to do here. Zeros method is for echelon form only. But why we are making zeros here is to show that determinant is 0. Okay, no need to find determinant everything. So see, we have this question. First we should have every time here 1. So R1 and R2 I'm interchanging. Okay, for convenience I fastly edit like this. Next I want zeros here and here. How many are possible I'll make. So I'll write R3, R3 minus 3R1, R4, R4 minus R1. See, now so clearly you can see they're identical. So if I subtract R3 minus R2, R4 minus R2, so there will be zeros, right? So I'll get whole 2 rows as zeros only, which means see if whole fourth row is, that means fourth determinant and third minus and fourth minus are both zeros. So clearly rank of A is not equal to 3 or 4, right? Because in fourth order, if one row is 0, then anyway any determinant you find it will be 0. And coming to third, any you take 3 cross 3, because 2 or 0, no? So anywhere you take it will be zeros only. So pakka third determinant and fourth determinants you are getting 0. Now we have to go to check for second determinant or minor 2. See this one, any one you see. If any one is not equal to 0, then rank will be 2. If I see 1 0 0 1, so 1 into 1 minus 0, it will be 1. So consider this 1 I got, which is not equal to 0. Therefore, rank of matrix is 2, because this is 2 cross 2. Like that we have to find. So this type of questions are important. Find real value of k such that rank is 2. This is 3 cross 3 matrix, but they're telling rank is 2. What that means? Third order minor of A should be 0, right? Only then rank will come from 3 to 2. So third order minor is 0 means that is 0. So after finding that equation, you'll get k value. K cube is 1 means k values are 1 omega omega square. So Euclidean form is very easy. If I have to find A using Euclidean form, first I have to make sure that first element is 1. And then I have to make sure that all this triangle should be zeros. So I have to bring it. So I told you first operations whatever you do, R1 should be there this side. Second time operations R2 only should be there. Only then without confusion you will be able to do correctly. So after that, this is in my Euclidean form. See 0 0 0 0 0 0. So this is in Euclidean form. So now rank is number of non-zero rows. So number of non-zero rows is 2. Therefore rank is 2. This is through Euclidean form. So define rank of a matrix and find all values of k. What is the rank of a matrix? Rank of matrix, at least one non-zero minor should be R. Okay. So see this, find all values of k such that rank of A is 3. So this is 4 cross 4 matrix and they're telling that rank is 3. That means I can rightly write that is not equal to 0. Only if that is not equal to 0, then rank will be 3, right? So I got this. I took any one, you can take any three cross, any 3 cross. And then from not equal to 0, so k is not equal to 0. That means value can be any real number except 0, like that. So system of linear equations. Okay, it is of the form Ax is equal to B. A is called coefficient matrix, B is called variable matrix, X, B is called constant matrix. So here we have two types, consistent and inconsistent. Inconsistent means no solution. Consistent means yes, we have solution. When do we say consistent? If we have find rank of A by B is equal to rank of A, then we say it is consistent. If it's not equal, inconsistent, that means no solution. Okay, no solution. Here we have solution. That solution can be unique solution or it can have many solutions. How we'll find which? If it is equal to n, then it is unique. If it is less than n, then it is infinite. That's it. Okay, so now coming to homogeneous. Homogeneous means Ax is equal to B is there, no? Here nothing will be there. It is zero matrix. In such cases, B is only not there means, see, this and this will be always equal. So homogeneous are always consistent. They will always have solution. There is no such case as inconsistency. Okay. So we have to see only these two cases. In homogeneous, when it will be unique, if rank of A is equal to n. If rank of A is less than n, it is infinite. So there is no such case as inconsistent in homogeneous. Either it is equal to n, then we'll have unique solution. That unique solution is also nothing but x is equal to 0, y is equal to 0, z is equal to 0. That's it. If it is less than n, infinite solutions we have to find. For example, we will be given like this. So we have to form A, X and B with the coefficients, X coefficients, Y coefficients. So X and Y, Z are variables, constants in one. So now first we have to find augmented matrix. Augmented matrix is nothing but we have to mix A and B and put a dash. That's it. So first we have to find rank. So we are making it Euclidean form. After making it Euclidean form, now we have to find rank. See, focus on this matrix. Rank of A by B means whole. Consider this whole matrix. How many non-zero rows are there? 1, 2, 3. Therefore, rank is 3. Now consider only rank of A. Means only this. So in this, how many non-zero rows are there? 1, 2, 3. Right? So this is equal. That means it has a consistent solution. Means it has a solution. And n is equal to 3. Right? X, Y, Z. So n is 3. Therefore, system is consistent and unique. Now we have to find the unique solution. That means you have to find values of x, y, z. From this only we can write easily. Using this matrix only, we'll put zeros and we'll get. So see this question. Here, rank of A by B is 2, rank of A is also 2. That means system is consistent. And when it coming to n, we have 3, x1, x2, x3. So n is consistent, but it is having infinite number of solutions, right? So using this, we'll write these equations. Now, the trick here is n minus r. N minus r is 1. That means you have to take one variable as k. If n minus r is 2, you have to take any two variables as k1 and k2. Here n minus r is 1. So I'm taking x1 or x2, x3, any your wish. You have to take k and you have to put it. Now it will be easy to solve. So you'll get values in terms of k, right? So this is your solution set. X1, x2, x3 is your solution set. This is how, because infinite number of solutions, right? So you can put k value 1, k value 2, k. So infinite number of solutions you will be getting. That's why we'll have k in the solution. So this is one interesting question. Find the value of a and b. We have to find the value of a and b such that the equation is unique, no solution, infinite number of solutions. First we'll make it into echelon form. So now unique solution. So see, when it will have unique solution, when rank of a by b, rank of a is equal to n. So see here. So rank of, so here already n is 3, right? N is 3. So rank of a by b and rank of a should be 3. That means a minus 3 should not be equal to 0. If I have any constant here, then number of non-zero rows will be 3 and here also 3. Therefore, a minus 3 should not be equal to 0. B can be any value. Then it will have unique solution. Okay. Next, no solution. No solution means inconsistent. So rank of a by b should not be equal to rank of a. Here, if a minus 3, if it here 0 is there, then the whole, see, and b minus 10 is not equal to 0. Here 0 is there and here some constant is there. The number of non-zero rows will be 3. So rank will be 3. But here 0 is there, no? Because so rank of a will become 2 only. Number of non-zero rows is 2. So in such case, a minus 3 is 0, b minus 10 is not equal to 0. In that case, we'll have no solution because their ranks will not be equal. Next is infinite number of solutions. When will we have infinite number of solutions? Rank should be equal but less than n. Here n is 3. So rank should be 2. When we'll get rank 2? Both rank should be 2. If this is 0 and this is also 0. So a should be 3, b should be 10. See, if this is 0 and this is also 0, the number of non-zero rows will be 2. In rank of a also will be 2. So rank of a and a by b will be equal, but they will be less than n, which is 3. In so, we should write like this. A is 3, P is 10. So this will be 0, this will be 0, then their ranks will be equal and they will have infinite number of solutions. So eigenvalues and eigenvectors, very simple. So first they'll give you a matrix. For matrix you have to find det, A minus lambda I. And then you'll get an equation, right? The roots of that equation are called eigenvalues. And eigenvectors? Eigenvectors are nothing but Ax is equal to lambda x. We get them from A minus lambda I into x we'll do. So eigenvectors will. Example C. We got a matrix. So characteristic equation you can find either det or for like this you can remember easily. For 2 cross 2 this is the characteristic equation. For 3 cross 2 this. For 2 cross 3 for 2 cross 2 lambda square minus trace means this, no, diagonal 1 plus 2 3 minus 3 lambda plus determinant, it's minus 10. So lambda values minus 2 comma 5. So these are my eigenvalues. Now eigenvectors, a, I told you, no, a minus lambda into x. So eigenvector corresponding to minus 2 and eigenvector corresponding to 5 we will find. So how we will find this? A plus 2i into x is 0, or you can write ax is equal to, so be it like this only. So we'll write 1 4 3 2 plus 2 into I means 1001 into x means x1 x2 0 0. So now if we solve, so we'll multiply and we'll add, so we'll get 3 4 3 4 x1 x2 0 0. That means we get two equations from this, 3x1 plus 4x2, and another equation is also, so we'll put x2 is equal to k, and then we'll write 3x1 plus 4k is 0, so x1 is equal to minus 4k by 3. So x2 is k. Therefore, your solution matrix is x1 is x minus 4 by 3k, k, x1, x2. Okay. So similarly, we'll find for eigenvector corresponding to 5 also. A minus 5i into x. Okay. We'll put x1. So see here, we get x1 is equal to x2. Therefore, k, if we take k common, 1 comma 1. So see this question, we get A. So characteristic equation lambda cube minus trace of A lambda square. So we got lambda values 8, 2, 2. So when we get repeated roots like this, we have to pay focus. For 8, we'll easily find A minus 8. Okay, we'll get answer. We are making zeros to make the solutions easy. If we make zeros, so we can write x2 is x minus x2 we got. So we'll take 1 as k and we'll get the solution equation. This is easy. 2 comma 2, we have to do it like this. So we have to take two numbers x2 k1 x3 k2. Remember, whenever you get two repeated roots, so we have to take two variables as k1 and k2, and then you'll get like this k1 minus k2. And in solution, when you're writing, if you want you can leave it here, or else if you want to write, we will one way put k2 0, and you let k1 k2 you'll get, no, so 1 by 2 1 0, and in next thing put k1 as 0, so minus 1 by 2 0 1 you'll get like that. So Cayley-Hamilton theorem is very easy. It just every square matrix satisfies its characteristic equation. Characteristic equation will get, no. So square matrix we have to put in lambda plus a, that's it, and we have to show LHS is equal to RHS, that's it. And sometimes I'll ask you find A inverse by using Cayley-Hamilton theorem. Then you'll find everything as we did before, eigenvalues, eigenvectors. Okay, after finding by CHT, in place of lambda you can put A, right? And now multiply that with A inverse. And from the constant here 6 you'll get, no, from here you'll write the A inverse. And this you can find using calc. So from the given equations using coefficients A, H, G, H, B, F and GFC, we'll write a matrix, and from that we'll find eigenvalues and corresponding eigenvectors. After that we have to find normalized vectors. Normalized vectors we use and we write new matrix called P. Okay. Now we have to write P trans. Now x1, x2, x3 are orthogonal. So directly P inverse is equal to P transpose. So we consider P transpose into A into P, and after multiplying the 3, we get in diagonal 0, 3, 15 here. And now we'll write x transpose. The given equation is x transpose AX. Now we are equating it with x is equal to PY. So we'll multiply PY whole transpose A into PY. And now we'll get y transpose dy. So the D is the diagonal matrix, and y transpose and y will write like that, and we'll get one equation, so which is the required canonical form.